Hey guys, welcome to part 2 of my video on surds. In this video we're going to run you through the common styles of exam question that can come up. This includes multiplying and simplifying surds, rationalising two-term denominators, and rationalising a denominator with two surds. We're going to be using all the things I mentioned in part 1 of this video, so if you haven't watched that already, you can find that in the link in the description. Let's get started. So for our first question, it says, can we simplify these two brackets here? So we need to multiply them out first. So root 12 times root 12 would just be 12. And root 12 times minus 2 would be minus 2 lots of root 12. 2 times root 12 would be plus 2 lots of root 12. And 2 times minus 2 would be minus 4. So our surds in the middle cancel each other out. And we're just left with 12 minus 4, which would be 8. Then it says, can we express root 12 in the form m root 3, where m is an integer? Well, we can actually take a factor of 3 out of 12, so let's do that first. So root 12 is equal to the square root of 4 times 3, which we can then think of as root 4 times root 3. Root 4 is simply 2. So that's just 2 root 3. So m must just be 2. The next question says it's given that x is root 3 and y is root 12. Can we find in the simplest form the values of x times y, y over x, and x plus y all squared? Well, the first thing I would do is actually root 12. We can write that in terms of root 3. We saw that in the last question. So let's do that. Root 12 we saw earlier was simply just 2 root 3. So then part A, we've just got root 3 times 2 root 3. And then root 3 times root 3 is 3, and then 2 times 3 is simply 6. So part A is just 6. Then for part B, we've got y over x, so 2 root 3 over root 3. And then our root 3's just cancel, leaving us with 2. Then for part C, we've got x plus y all squared. So that's root 3 plus 2 root 3 all squared, which is simply 3 root 3 all squared. And then 3 squared is 9. Root 3 squared is 3. 9 threes makes 27. For our next question, it first says, can we express root 5 in the form of n root 5? And again, we can pull out a factor of 5 from 45. So root 45, we can first write that as root 9 times 5. And then we could write that as the square root of 9 times the square root of 5. Root 9 is simply 3. And then we just have 3 root 5 then. Next up it says, can we solve this equation? X times root 20 equals 7 root 5 minus root 45. Well, first we can notice actually that root 20, we could write that also in terms of root 5. So let's do that first. Root 20 we could write as the square root of 4 times 5. So root 4 times root 5, which is simply 2 root 5. So then writing out our equation, we've got x times 2 root 5 would equal 7 root 5 minus 3 lots of root 5. So we've got x times 2 root 5 would equal 4 lots of root 5. And then we can cancel off a factor of 5 from either side. So we have 2x is equal to 4, meaning x would just equal 2 if we divide by 2 on each side. Next, the next question says, for part A, can we express 5 plus root 7 over 3 minus root 7 in the form of m plus n root 7, where m and n are integers? So we need to rationalize the denominator, basically. So let's start just by writing out our question. So 5 plus root 7 over 3 minus root 7. And to rationalize the denominator, we need to change the sign of one of the terms in the denominator and multiply that through onto the numerator and denominator. So I'm going to change the sign of the root 7. So I'm going to multiply by 3 plus root 7 in the numerator and the denominator. And now we just have to complete the multiplication, making sure we actually do every multiplication. So 5 times 3 would be 15. Then we have 5 lots of root 7. Then we've got root 7 times 3, so 3 lots of root 7. And then we've got root 7 times root 7, which would just be 7. And then at the bottom we'll have 3 times 3, which is 9. 3 times root 7 is plus 3 lots of root 7. Minus root 7 times 3 is minus 3 lots of root 7. And minus root 7 times plus root 7 is just minus 7. Oops, minus 7. And then we can see our trick has worked as we wanted it to, so the surds in the denominator cancel. Now we can just start simplifying. So 15 plus 7 in the numerator, that's 22. And 5 lots of root 7 plus 3 lots of root 7, that's 8 lots of root 7 in our numerator. And in the denominator, we just got 9 minus 7, which is 2. So cancelling off a factor of 2 everywhere, or dividing through by our 2, 22 over 2 is just 11. And 8 root 7 over 2 would just leave us with 4 lots of root 7. So m must be equal to 11, and n must be equal to 4. And for part B of the question, we've got a right angled triangle. It says the hypotenuse has length 2 root 5. The other two sides have length 3 root 2 and x centimeters. Can we find a value for x? Well, it's a right angled triangle, so we can use Pythagoras' theorem to find x. So for part B, then, we can say 3 root 2 squared plus x squared must equal 2 root 5 all squared. 3 root 2 squared, well, 3 times 3 is 9. Root 2 times root 2 is 2. 9 times 2 would be 18. So then we'd have 18 plus x squared would equal, and then 2 root 5 squared, that 2 times 2 would be 4. Root 5 times root 5 would be 5. 4 times 5 would be 20, so that will equal 20. Meaning we'd have x squared would equal 2. So x could equal root 2 or minus root 2, but minus root 2 makes no sense in this question, so the solution would just be root 2. For our next question, we've got another fraction. We've got 11 root 3 plus 2 root 5 over 2 root 3 plus root 5. And it wants us to write it in the form of m minus root 15, where m is an integer. And again, all we need to do is rationalize the denominator for our two-term denominator. And the fact that there's two surds in the denominator isn't actually going to change anything in terms of what we do. We have to just swap one of the signs again and multiply that through onto the numerator and denominator. So let's start by writing out the fraction again. So 11 root 3 plus 2 root 5 over 2 root 3 plus root 5. And I'm going to swap the sign of the root 5. So I'm going to multiply by 2 root 3 minus root 5 on the top and bottom. And if we carry out the multiplication now, so we've got 11 root 3 times 2 root 3. Well, 11 times 2 is 22. Root 3 times root 3 is 3. And 22 times 3 is 66. So you have 66. We've got 11 root 3 times minus root 5. Well, root 3 times minus root 5 would be minus root 15. So we'd have minus 11 lots of root 15. Then we've got 2 root 5 times 2 root 3. So that would be 4 lots of root 15 plus 4 lots of root 15. And then we've got 2 root 5 times minus root 5. Root 5 times minus 5 would be, root 5 times minus root 5 would be minus 5. And then multiply that by 2, we get minus 10. And then the denominator, I'm going to have 2 root 3 times 2 root 3. 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 is 12. Then we've got 2 root 3 times minus root 5. that would be minus 2 lots of root 15. Then we've got root 5 times 2 root 3, that'd be plus 2 lots of root 15. And then we've got root 5 times minus root 5, which would be minus 5. So again, our surds and our denominator cancel as we wanted them to, and we can start simplifying. So in the numerator, 66 minus 10 is 56. Then we've got minus 11 lots of root 15 plus 4 lots of root 15. That would be minus 7 lots of root 15. And then 12 minus 5 is 7. And actually, we can divide the whole numerator by 7. 56 is just 8 7. So we'd have 8 minus root 15. And that would mean that m, our integer to find, was 8. That's the end of the video, guys. I hope you found it helpful. If you did find it helpful, please like the video. That helps me out a lot. And consider subscribing to the channel to stay tuned when I release more videos. Thanks, and I'll see you in the next one.